Section 4.4 is factoring quadratic expressions. I can find common and binomial factors of quadratic expressions, and I can factor special quadratic expressions. Big ideas here. Many quadratic trinomials can be factored into products of two binomials. The distributive property or FOIL method can be used to multiply two binomials. FOIL can be used in reverse to factor. So factoring is rewriting an expression as a product of its factors. Remember, factors are things we multiply together. So in order to write it in factored form, we rewrite our expression so that it's just the things that are multiplied together. There's no adding anymore or subtracting. It's all just being multiplied. So to factor an expression like x squared plus 6x plus 8, think of FOIL in reverse. We're going to find two binomials where the product of the first terms is x squared. So to get to x squared is x and x. The product of the outer and inner terms have the sum of 6x, and the last terms have a product of 8. So there's a lot of things that add up to 6, but there's only a couple things that multiply to 8. Our options are 1 and 8, and 2 and 4. We also need them to add to 6. So 2 and 4 are what we want. It's like we FOILed backwards here, in reverse. If I FOIL this to check, firsts, outsides, insides, and lasts. And that's the reason that the product of the last two and the sum of the last two both have to work for the same set of numbers, because our inside and outside combine like terms to give us our middle term of our trinomial. So we have to be careful here. We need to multiply to our last value and add or subtract to our middle depending on what our signs are. So here, I want to write my expression in factored form in number 1. I need to multiply to x squared. In order to do that, I get x and x. I need to multiply to 20, but also add to 9 with the same numbers. Add to 9, because my outsides and insides have to add to 9 when I combine my like terms, and my lasts have to multiply to 20. My options when I list out my factors for 20 are 1 times 20, which adds to 21. That's not what we want. 2 times 10, which adds to 12. That's not what we want. 3 doesn't go evenly into 20, but 4 does, times 5, which adds to 9. That's going to be our factors. So here, our signs in the middle of our terms are both going to be plus in this situation. We multiplied to a positive 20, which means both of our signs had to be the same. We found the sum of our numbers here, so our signs are going to be the same. They're both going to match the middle here, both be positive, because positive 4 times positive 5 gives me positive 9, and positive 4 plus positive 5 gives me positive 4 times positive 5 gives me positive 20, and 4 plus 5 gives me 9. So 4 and 5. To check here, we FOIL back. X squared, outsides, insides, lasts, combine our like terms, and we get back to our original amount. Same idea here. The only difference is we have a negative. So we're going to multiply to 72 still, and we're going to subtract to 14, because the only way we multiply to a negative number is if one of our numbers is negative. So if one of our numbers is positive and one is negative, we subtract our values, give the sign to the bigger number. So to multiply to x squared is still x times x. Options for 72 are 1 and 72, which subtract to 71. 2 and 36, subtract to 34, not what we want. 3 and 24, which subtract to 21, not what we want. 4 and 18, which subtract to 14. That's our winner. So here, when we subtract, we find the difference between our values. Okay, we subtract and find the difference between them, which means our signs are going to be different. One's going to be positive, one's going to be negative. We look at our numbers, the bigger number always gets a sign in the middle because we're saying we added to a positive 14. When we subtract, when we add numbers with different signs, we take the bigger number minus the smaller and then give the sign of the bigger number. So in order for it to have been positive, that means 18 had to have been positive and 4 had to have been negative. So every single time our bigger number gets a sign in the middle, whether our signs are the same. Up here, 5 was bigger, it got a positive, or down here where 18 is bigger, it gets a positive. Either way, the bigger number always gets a sign in the middle. The only difference is whether or not they're the same sign or different. If our last number is negative 72, the only way we multiply to a negative number is if our signs are different. Again, we can check here by foiling. Combine our like terms, we get the 14, and we are correct. In C here, we're going to rewrite this expression. We need just an x squared here, and right now I have a negative x squared. So I'm going to take and I'm going to factor out a negative 1 from each of those terms. And then I'm going to multiply by what's left. It's kind of like we've done with absolute value and with quadratics before, when we have to take out what's common in order to rewrite them in vertex form. Same idea here. We take out what's common, but it still needs to be accounted for because we have an expression here, not an equation. So everything still needs to be there in order to get back to where we started. The negative 1 still has to be accounted for. But now we can factor this. To multiply to x squared is x times x. We still have that negative 1 factor. It's something that's being multiplied. It stays. I'm going to multiply to 12. Add to 13, and I add because right here's a plus. Multiply to 12, add to 13. My options, 1 and 12, is 13. I found it right away. I checked to see what my signs are going to be. Since we found the sum here, it means my signs are going to be the same. We check the middle, they're both negative. So it's a negative 1 and a negative 12, which multiply to a positive 12 and add to a negative 13 there. So negative 12, negative 1. Negative 1 times x minus 12 and x minus 1. If we FOIL back here, FOIL first, x squared minus x minus 12x plus 12. And then multiply by our negative 1 gives me negative x squared plus 13x minus 12, which checks. Now, feel free to pause here and give this a try if you'd like. We are going to multiply to 40 and add to 14. It has to satisfy both. So 1 and 40 gives me 41, not what we're looking for. 2 and 20 gives me 22. 3 doesn't go evenly into 40, but 4 does. 4 times 10 gives me 14. That's going to be the combination we want. So to multiply to x squared is x and x. We know our numbers are going to be 4 and 10. We got to check our signs here. Because we found the sum, my signs are going to be the same. Here they're both going to be positive. So there's my factored form. If we FOIL it back, we get what we need to there. So that quick check by foiling works. In B, here, I'm going to multiply to 30, add to 11. We add to the middle because that's where we combine our like terms. My options for 30 are 1 and 30, 2 and 15, 3 and 10. 4 doesn't go evenly into 30, but 5 does, 5 and 6, which is 11. So we are good to go there. To multiply to x squared is x and x. We said to multiply to a positive 30, our signs have to be the same. We found the sum, so our signs, our signs are the same. We checked the middle to figure out what they are. Negative. It was a negative 5 times a negative 6 that gave us a positive 30, and that negative 11 in the middle that we were looking for. In C here, before we can factor, we have to look. Our x squared is negative. We don't want that. We want a positive x squared. So I'm going to take a negative 1 out of all these. Again, we want our first term to be just x squared, coefficient 1. I take out the negative 1, but remember, it still needs to be accounted for. It's still a part of our expression. We're just writing it a little bit differently, a little bit more user-friendly here. Now I can factor this inside part, what I have left after I divide out the negative 1. Again, negative divided by negative is positive, positive divided by negative is negative, positive divided by negative is negative. I'm going to multiply to 32, my last number, and use the sign in the middle here to tell me I'm going to subtract to 14. Options are 1 and 32. Nope. 2 and 16. Yep. So here, I keep that negative 1. It still has to be a part of my expression. To multiply to x squared is x and x. Since I found the difference, my signs are going to be different. I check my values. My bigger number always gets the sign of the middle term. And here's the opposite. So I get negative 1 times x minus 16, x plus 2. The greatest common factor, or GCF, of an expression is a common factor of the terms of the expression. Okay, so we're going to take out the greatest common factor. That's going to be our first step when we factor, always, after not panicking, is to take out what's common. So here, if you don't recognize right away what's common between them, we can use a factor tree and write out our factors. So 6 is 2 times 3, and then we have n times n. 9 is 3 times 3. I put a 3 in my 3 column. I make another column for 3's because I don't have one. Anything that's, and an n. Anything that's a full column, like we have 3's in both and n's in both, that comes out as a common factor. What that's telling me is that 3 is a factor of both of them and n is a factor of both of them. 3n then is my greatest common factor. I multiply by everything that's left, and each row is its own term because each row came from its own term. And it's a positive 3 there. So 3n times 2n plus 3 is my expression in factored form. Some of you may have looked at this first and saw that between 6 and 9, 3 goes into both of them, so you divided out a 3. And between n squared and n goes into both, so you took out an n. Since we took those out, we divide them out. What we have left is 2n plus 3. So either way, this way it just helps us make sure that we don't have any factors that we missed, that we actually have our greatest common factor, as long as we break down our factors in our factor tree to their prime components. So same idea here with B. 4 20 is 4 times 5. I put a 2 in my 2 column, a 2 in my 2 column. I make a 5 column and an x in my x column. Here I have 7 times 8, which is 4 times 2, which is 2 times 2, and a negative 1. So I'm going to put a 2 in my 2 column and a 2 in my 2 column. And I don't have another 2 column, so I'll make one. I don't have a 7 column, so I make one. And I don't have a negative 1 column, so I make one. If I look here, things that I have common are a 2 and a 2 in both. So I can take out a 2 times 2 or a 4. 4 is my greatest common factor. I have one factor of 2's, a second factor of 2's, and I multiply by what's left, x squared plus 5x minus 14. We check if this factors further. We want to multiply to 14 and subtract to 5. 1 and 14 don't, but 2 and 7 do. So 4 times x plus 7, x minus 5. We found the difference here, so my signs are different. 7's bigger, it gets a sign in the middle. And this multiplies back to our original expression. And again, we could have looked here, and if you recognize that 4 is a common factor, you can divide that out, keep it accounted for, and we get to the same spot. I'll finish in another video.